Hello everyone, thanks for watching my presentation. I'm Xueli. The topic of my presentation is a reliable wireless smart vehicle, highway on-ramp merging protocol with constant time headway safety guarantee. The purpose of my presentation is to develop a reliable protocol for highway on-ramp merging scenario. I'm going to divide my presentation into 3 parts: highway on-ramp merging scenario, cooperative merging protocol, and the congested theorem. First, I'd like to start with the highway on-ramp merging scenario. As you can see in this figure, there are 2 lanes. The highway lane is modeled as a real number axis, and the on-ramp lane is modeled as a half lane. The intersection is the merging point, P-merge. This label represents the base station. It's responsible for coordinating highway vehicles and the on-ramp vehicle. Initially, there are n highway vehicles driving on the highway lane. From the merging point backward, we label it as H1, H2, so on and so forth to Hn. At first, the on-ramp vehicle is stopping at the entrance point on the on-ramp lane. It sends merge request to base station. And then, according to the estimated arrival time of highway vehicles and the on-ramp vehicle, it sends corresponding message to vehicles. When the on-ramp vehicle gets permission from base station, it starts accelerating to merge onto the highway lane. During the merging process, we guaranteed the constant time headway safety rule. Basically, it means for any 2 vehicles driving on the same lane, Hi plus 1, the distance between the 2 vehicles at any time t is no less than this value. V is the speed of the vehicle Hi plus 1, and the delta star is the desired time headway. Second, I will introduce our protocol. We gave 3 hybrid automata. This is a hybrid automaton for the base station. This is a hybrid automaton for the on-ramp vehicle, and this is a hybrid automaton for the highway vehicle. Because of the time limit, I will skip the details of a hybrid automata. Interested people can look into our paper. Here, I want to bring your attention to 3 features. First, the exclamation mark means the wireless packet is sent. Second, the question mark means the event is triggered upon the reception of the wireless packet. We use double question mark to indicate the wireless packet may be lost during the transmission. And last, in each node, the differential equation describes the continuous dynamics. All notational rules can apply to hybrid automaton for the on-ramp vehicle and the automaton for the highway vehicle. Lastly, based on the protocol, we conjecture the theorem. Given configuration parameters and linear constraints, then we have 2 claims. The first claim is on safety. Basically, it means the constant time headway safety rule is always guaranteed, so there will be no vehicle collisions. The second claim is on liveness. Basically, it means the holistic system will always reset itself, so there will be no deadlock. That concludes my presentation. Thank you.